The initial sketch of our spin part is complete. We will now finalize the part by changing and verifying all the details. First thing is, let's set it to the right height. So we're going to check marker 2. Maybe even better, let's rename marker 2 because its task is the reference of the base sphere. Actually, we're going to call it the reference of the complete spin because it's the most convenient marker to handle the whole part. Okay, marker reference, modify. So it's now at 22 millimeters above the ground, which is, well, supposed to be reasonable. It's going to fall down, make contact, and then it's going to be dynamically behaving. Okay, the top sphere TS, rename the marker of that, ref TS. That marker is going to be 24 millimeters above the center of the BS, which was at 22, so this should be at 46 millimeters. Apply. So this is what the description of the spin model says about the position of the contacts. Next thing to do is let's modify the inertia. As you see here, Adams is now using the volumes to calculate the inertia. It's based on steel, which is a default, and you can actually show the inertia here. So based on steel, this spin would weigh about 190 grams. What we want to have is we want to have a spin part weighing 16 grams, with defined inertia tensor. So let's switch over to user input, type 16 grams here for the desired mass. Okay. And we type the values of the desired inertia, Ix, Iy, Iz, okay, which is going to be 2.4 kilogram per second. I meant kilogram millimeters squared, so I filled it out for the three values, so Ixx, Iyy, Izz. The only thing to remember is that from the drawing you can understand that Izz is going to be inertia about the vertical axis. Now we have to map the z-axis in which we define the inertia with a proper z-axis. So let's check what the current axis is. Select marker center of mass. This is the default name in Adams for center of mass markers, and we see that indeed the z-axis of the center of mass is pointing upwards, meaning that we are doing it in the right fashion. This Izz is in the right direction relative to the local frame of our spin part. So with that we have completed the inertia of our spin part.